So with our last two examples on this topic, we're going to get a little meta. It is not at all uncommon for mathematicians to use numbers to count numbers. And often we're going to be building a number. So in this case, we're asking ourselves, how many possible 6-digit even numbers are there? Well, again, the first step is to set out our blanks. We have 6 blanks. We know we need the first digit and the second and the third and the fourth and the fifth and the sixth. So these are all multiplications. But now we need to decide how we approach this. The most effective approach I find is to start with the most restricted digit. Now the digit that is subject to the tightest restrictions is the last one. To be an even number, your number has to end with either 0, 2, 4, 6, or 8. So that leaves us with 5 options in this blank. Our other restricted digit is not that obvious. It is very, very tempting to just go 10, 10, 10, 10, 10, and 5, and say that we have 500,000 options and be wrong. Because if this leading digit is a 0, then we don't have a 6-digit number anymore. It's only a 5-digit number. 0 is not allowed in your first digit in almost any of these digit counting problems. So our first digit only has 9 options, not 10. Now we have no other restrictions on the other 4 digits, so we can multiply them all together. And in the end, we find that there are 450,000 even 6-digit numbers. Now, we could argue that it would have been easier to start with these middle 4, and in this particular problem, that would have worked out fine. In our next example, and the final example for this series of lessons, that would have been a bit of a problem. So we will see exactly how that comes up in our next example.